I'm glad to see so many people in Prague. Like, it's totally heartwarming for me to see how many mobile security enthusiasts we managed to invite there and who actually decided to join this conference. Because most importantly, you are the closest community we have. And today I want to show you what makes Talsec a community-based company and how we are community-driven and how we consider our security being community-driven. So in Talsec, we currently run on almost 2 billion devices, or maybe sometimes a little bit more, and we protect thousands of applications. These are, of course, the deployed applications with end users, but behind these applications, behind each of these applications is some developer who decided to include our technology stack, who decided to ask us questions, who decided to test this application, who gave us the trust that this SDK makes sense for them. So there are not apps, there are not devices, but there are real people, developers, users who contribute to Talsec just by adopting the technology stack. And we don't have only adopters. We have, of course, adversaries or attackers. And what I think is most important is that both communities are equally valuable. Because I think that our attackers would find this funny for me to consider them like our community. But in fact, whenever someone publishes a write-up regarding some weakness in FreeRASP or contributes with some vulnerability they found, they are actually doing the community work by contributing us with unnecessary inputs, what we need to improve, what we need to get better in, what we need to strengthen. So our community are both good ones, adopters, who open issues on GitHub, who fill in tickets, who complain sometimes about some stuff, but also attackers who contribute by doing pen tests, by breaking into the SDK, by finding what's weak and what needs to be done to bypass something. Both these communities are equally important for us. In Talsec, we have key security challenges that arise from device and OS fragmentation. Because as you may imagine, there are already 16 or 17 Android versions, and I don't count even minor ones, only major ones. There are so many iOS versions, and keeping up with threats that evolve, new hacking methods, new tools, this is really, really cumbersome. Also, we need to maintain the SDK to be always compatible with the current state-of-the-art of build tools, build chains. For every platform we contribute to, for every platform we support, that's like not only native Android, not only iOS, it's Flutter, React Native, Capacitor, Cordova. Recently, we even decided to go into gaming sector, so we also tried to implement our SDK in Unity and Unreal Engine. So we need to know what works, what people need. We need their feedback. So our communities, what I say is like global QA team. Because developers who adapt our SDK are actually able to test it on a scale we would never do internally in a lab. Like how we could do it. Like there are like 20, 30 Talsec people, but there are thousands of developers who test the SDK in their applications, who run it on most interesting and weird devices under most unthinkable scenarios. So yeah, these developers, hundreds of issues and discussions we tracked across all platforms, and you can easily see that this is unthinkable to maintain without the help of the great community we have. Speaking of edge cases, in the laboratory everything works, but we can't ship our computers. So we need to adapt our SDK and we need to fix it for the most unthinkable edge cases everywhere. Like there are devices that come like pre-routed from factories. There are various TV boxes. There are various payment kiosks, or even Raspberry Pis that run Android. And we need to fix it everywhere. So getting the coverage everywhere is very important for us and wouldn't be possible without people who decide to help us, to give us feedback, to test things for us. So I have a few samples there, like I remember like there were some recently key store race conditions because key store is not always the same on different devices, or the media DRM is different between different devices. And some budget devices may have even non-standard behavior. So making it right everywhere is very complicated. And speaking of adversaries, so-called pen tester team, free pen tester team, these community exploits are actually gift. We learn from these public exploits a lot. These public exploits, for example, on Frida Code Share, help us to see what people were able to breach. What they found was weak, what they found was still hackable. So we can right away develop fixes and think of things that may be important and how to improve it. I want to also give like a highlight to recently released FreeRASP or RASP 17, because this is one of the most packed releases we did in the last years, I think. This latest release comes with like dozens of changes, and I took some time to label these. So the red one is a bypass, a community adversary found. We added a lot of enhancements people requested. We also fixed a lot of bugs that came from community submissions and issues. So each of these labels is actually something we were able to fix or improve thanks to the community feedback. Also, a lot of time, we don't talk about this a lot, but in FreeRASP, we have a quite developed feature testing system. FreeRASP comes with like internal feature testing stack that allows us to like test various ideas in the field without affecting the verdicts. So we can always check if something works or not by activating various feature tests on FreeRASP. They are set in ignore mode, so they don't affect the verdicts, and they are separated from the telemetry logs, so they don't mix up with real data, so you don't have to worry about them, but they help us a lot. And what's important is that since we develop a single SDK, so every single bug, every single feedback and enhancement we make, which is made from, for example, on behalf of single developer who found the issue, is actually something we will fix for everyone. So this one-to-many to one SDK fix, this great feedback loop allows us to develop the greatest RASP. I think that we are currently the most used RASP in the world. So this is also thanks to the awesome community we have. Of course, we get a lot of various feedback also from different areas. I just an hour ago I talked about free malware detection in the next room, and the intelligence, how to configure these malwares, how to work with the product. This is also working only thanks to the feedback system through the feature testing we have. So we are able to test this malware detection in public with people's help. Similarly, for example, Google Play review process is a great black box, as you might know, some of you. sometimes we really don't know how they do their decisions. But thanks to the community feedback, we were able to do decisions how to shape our SDK so it works for everyone without affecting the Google Play review process. And there is also something we want to always give back to community. So Talsec does a lot of writings, sharing. As you maybe know, we have also authors programs. So if you are interested in sharing like mobile security knowledge, we offer like authorship programs. And we write a lot about mobile security and share our knowledge with the world. Similarly, not sure if, no, he's not with us today. We have a colleague there with whom we shot a lot of nice videos, so you may also check on YouTube. And I think that we also are able to contribute in more structured way on OWASP mobile application standard project, where we contributed with a routing article recently. And one of the last things we recently introduced for the community is Talsec portal, where you are able to see data, see stats, trends, and global like state of mobile security. So this way we can give back community what we learned. So also community may then benefit from this knowledge. That's all how we work with community, and thank you for being there with us. Thank you.
Thank you, Tomáš. Any questions?
Hi, maybe I would like to ask you about like the, let's say, success rate of your Talsec RASP in a way that it says SDK which is packed in the APK, so given the Android security model, you are basically operating something like untrusted application, if I'm correct.
I don't get the part about the trusted application.
What I'm trying to say is that you control a lot of stuff on the system. For example, if it's rooted, if, I don't know, like Freda is injected into the process, etc. At least I assume.
Yes, but from the application, not from the system side.
Yeah, and what I am like trying to point out is that if I'm an attacker and I have like rooted device, then I'm operating from the root user. Therefore, I'm like much more higher in the privilege stack compared to your SDK. So if you have any like technical details how you basically check for the rooted devices, Freda injections, etc.
Like our technology works when the application is running, it's a runtime application, self-protection. So during runtime of app, we check these things.
So basically, I can imagine it like you are scanning, for example, the memory of the application the SDK is packed into.
Yeah, okay. Memory of application, no like remnants of routing frameworks, some leftover files and things like that.
Yeah, okay. Thank you very much.
Thank you.
Any more questions, comments, discussion points?
Thank you. Are there any issues with app review regarding RASP? Have you experienced any of that? That, for example, due to some RASP permissions or how RASP works in the runtime, I don't know, some app review was affected, or someone from the Apple app review team was not, I don't know, was experiencing some stuff like that, or maybe another thing very much related. I remember that Google Play was running some automated tests on emulators, and they all crashed because the RASP checks for emulators and so on. So what's your experience on that?
That's pretty precise observation here that also happened to us. Regarding the success rate, we have like, I would call like 99.999 several nines rate. Yeah, I remember there were like 1 or 2 cases where we were rejected by Google Play or the like application adapted SDK, but it got always sorted out with the feedback, with the communication with Google Play support, although it may take some time sometimes. So yes, you are right that the Google Play review process is partially automated, partially done by hand with like random results. So sometimes there are real people who test your application on emulator and then just block your release process without even noticing like or giving you proper response what they found was wrong. Otherwise, but usually it's no problem. Speaking of permissions, Talsec SDK doesn't hold any dangerous permissions or doesn't require any of them, so you are pretty safe with them. Thank you for the question.
Hi, thanks for a nice talk. I'm not really that much into RASP and mobile, so but I wonder, how do you decide what goes into the free RASP and what stays behind the paywall, let's say, or some payments? In particular, whether you aim to have free RASP as secure as possible, and the paid stuff is basically like convenience then, and maybe statistics, etc. Or what's the how do you navigate this space so that like the community has maybe the best security possible, but there's some
Thank you for question. It could be like another talk on this topic, but I will highlight that we intend to make free RASP as secure as possible within the limitation of the technology we have for free RASP. So, for example, there were recently like some bypasses regarding the UI callbacks delivery, which are not a problem for the RASP Plus commercial version. But for free RASP, this can't be solved because we would need to have like more things in the build process to prevent this. So we are like, in general, we don't harm the security of free RASP against the RASP Plus. We try to make both maximum capabilities they can do within their what can be achieved in the current state of the tech we have.
So I'm not sure how technical a question it is. I'm also not so much into RASP, but if the SDK is a separate process that needs to be initialized, how do you ensure that the app cannot run without initializing the Talsec SDK?
Thank you for the question. SDK runs in the same process as your application. It's the same process. And how to ensure that it was run, this is exactly something that can be only solved with the commercial solution we call AppyCrypt, because this is the only way how we can know in the app that previous job from SDK was done and was then transmitted to backend. So this is something that can't be done purely on the client. So yeah, there is technically a problem that the SDK could be cut off from the main run, but it isn't quite common. I haven't registered many complaints in this area. So I still believe this is more theoretical kind of attack. But thank you.
So there has to be like a network call to verify the process is running correctly?
It's a little bit more complicated. You send in the AppyCrypt once SDK finishes with some result, the AppyCrypt will contain this information about the run, and you will send it with your HTTP request as a header and process on your backend the results. So there is no backend call done on regarding the security, integrity of run. So it's one-to-one, point-to-point communication, no third-party server or anything like that in the process.
Thank you.
Thank you too.
I have one more question. Who is basically the clients? Is it the banking sector mainly, or what's the primary clients of the Talsec RASP?
It's like, I don't know exact numbers. I would say that majority are fintech and banks, and we also have health tech, e-government, and even game clients today. So even some industry clients. So yeah, but majority is definitely fintech, banking, and health tech these days.
Thank you very much.
Thank you for the speech. I want to ask about the AppyCrypt, like in summary. Can you just give a highlight on that?
Maybe we could do this offline then.
Okay.
I have 2 minutes. Okay.
Perfect.
So, AppyCrypt in 2 minutes. Imagine that you have a client, backend, and you need to see that RASP was run on the client. You need to have this proof that everything was checked, that RASP wasn't cut off. So with AppyCrypt, once checks are done, the SDK will provide you like an encrypted payload that you will add as a header to your HTTP call, whatever you need to call to your backend. Maybe it's just some initialization, like enrollment call to your backend, or I don't know, something like that. So first call you decide to make from your application to your backend, you just include this payload as a header. It's like 4 kilobytes, something like that. On the backend side, there is a thin like script that will check, like decrypt and check what's inside, whether all checks were performed, and some extra like routine checks that everything went smoothly. So on the backend, you will already know that everything was finished and what's the state of the device and application, and then you would just forward the request to your backend for further processing, or decline the request if it's not matching your security rules.
Okay. Thank you for that. So it's just basically a way to inform the backend whether to trust the client or not.
Exactly, yeah.
Thank you.
Thank you. I think we have space for one more question.
Then maybe as a follow-up, who manages the key? Because like if it's running the same process, why can the client reach the key and just encrypt the payload as if everything is processed correctly, but actually it's sidestepping the security? So you mentioned some kind of encrypted payload, so I wonder, like, where is the integrity coming from so that the app itself cannot basically malleate the payload?
Thank you for the question. This question is definitely beyond like 1 minute. I have a colleague who can explain whole security paradigm behind this called ephemeral cryptography. There are multiple keys on both sides that are in the process to ensure that it can't be breached easily. So, but most importantly, customer always manages keys. So customer is always in charge of his own keys.
Okay, then, thanks.
Thank you too.
Thank you so much, Tomáš. I think you can find Tomáš and other Talsec members at the sales table right out of the room, and they're happy to show you a demo even, right? There's demos happening, anything that you would like them to do. Thank you so much, Tomáš.
Thank you.